I'm Cliff Hall, and today I'm going to show you how to use audio modulation and easing to control the behavior and appearance of your sine wave plugins. Now this one's going to get a little in depth, so let's just dive right in. So the plugin that I want to show you today is called Sparks Fly. It generates a particle system with sparks, uses audio modulation and easing to control the brightness and the movement. So we're just going to go ahead and copy that and then take a look at it. You'll see that there are a whole bunch of settings that have been defined here. And they've been grouped into settings for the emitter, where we can position it in space, and we can control something called swing. Settings for the particle, including its size and its lifespan and its color. And then settings for particle motion, where we can limit the distance that the minimum and maximum distance that any given particle will travel. And we can specify curves for each particle's motion on the X, Y, and Z axes. And by using a separate curve for each of these, we get interesting motion as opposed to linear straight line motion between the place where the particle is born and the place where it ends up. Let's talk a little bit about the swing. On the emitter, the position of the emitter in space is whatever you fix it here with X, Y, and Z. But then that gets a little boring if all the particles are coming from that same point. So we'll swing the emitter around in space. Imagine tying a string to it and just whirling it around in space. So in order to affect that, we're going to have duration of the swing, how long it's going to take it to make it all the way from one point to another in its motion, and the radius, defining a sphere around the emitter, the point that the emitter is positioned in space. And so we'll be moving the emitter to points on that sphere. And we'll be using a curve to control our motion of the emitter on from point to point. And that won't be quite so complex a motion as we're defining for the particles. We'll just want to use one curve. And then we have modulation. In this case, the default is for the audio base to modulate the swing. So aspects of that swing are going to be controlled somewhat by the base or whatever the user chooses in the settings. So let's take a look at the code now. We'll notice that there is no destroy function because we're using the registration functions to register all the materials and geometries and so forth, so that the sine wave visualizer can free up memory when it's done, and we don't have to do any work to make that happen. And we'll see that what's happening on a frame-to-frame basis is very simple. We're going to spawn a particle, and then we're going to age all the particles. So we're just going to call two functions that we've predefined each time. So all the action is happening up here in the setup function. Let's take a look at what's going on there. We initialize on the context memory object, which is where we can store values and functions for later reference. We initialize a spark count and an array to hold all of the sparks that we generate. Now they're going to age, and once they've reached their maximum age, we won't be processing them anymore. But we'll continually be bumping up that count so we can register things with a new unique name using that number. So let's take a look at the various functions that are being defined in here to get things done. And we only call two functions, as you noticed from our render. we call spawn and age, and those are down here at the bottom. And these other functions do things like get the information about the swing for the emitter, set up the eases for the swinging, determining if the swing values have changed, because the user can change those settings during visualization, so we may have to create new easers at any given point if they decide to change the easing type for the swing curve, say. Get the emitter location, and that's going to be based on, again, the X, Y, and Z positions that are in the settings, and further by where the emitter happens to be on its swing curve right now, where it has been moved to. Then we've got some functions for the new sparks that we create. Find a target that we're gonna spawn this thing, and then we're going to fire it at a particular point in space. Get a spark lifespan, and that's going to give us how long any given spark is going to live. Again, that's limited by the user's lifespan setting and also modulated by audio. There's a lifespan mod setting. And we have spark size. Let's get a spark size. The user can say how big a spark can be, and then that's also modulated by the audio. Get the spark material. We create a unique material for every spark because we're going to individually manipulate the emissivity of them. Basically, we're going to put a texture on there or a color on there, and we're going to say that it's emissive, and we're going to change that emissivity over the lifespan with curve. So not only are we going to be moving things with curves, we're also going to be changing the appearance of things with curves, with easing curves. And so now let's go ahead and walk backwards through what happens here. Each time a render happens, we're going to call spawn first, and that's going to create a spark. So we're going to get the current spark count, which was initialized, and we're going to get a spark size by calling that spark size method. And we're going to get a lifespan for it by calling get spark lifespan, and we're going to get the emitter location by calling get emitter location. And remember, that is where it happens to be swinging right now, not just a fixed point in space. And then we're going to get the color, the current setting of the color, and we're going to create a material by calling get spark material, and we're going to register that material with a unique name. Then again, the registration helps Sinewav clean up after us, so it's an important thing to remember to do. Then we are going to create and register the spark geometry. In this case, we're going to use dodecahedron geometry for the sparks. And we're going to register that with a unique name. And then we're going to create the mesh. Create the mesh using the geometry and the material. And then we're going to position it by setting it to the emitter locations X, Y, and Z values. And then we're going to use the context to add this to the 3D scene. Next, we're going to get the spark target. We've got the particle, and where is it going to fly to? So we call get spark target, and we pass the current emitter location. So it's going to find some place between the minimum distance and the maximum distance from the current point. And then we're going to get the current setting of the particle motion X curve, Y curve, and Z curve. Again, remember, by using different curves, we create some interesting motion. If they were all the same curve, then it would just basically move in a straight line toward that point, and it might slow down and speed up as it goes, but it wouldn't be very interesting. You can test this by setting all three curves to linear or to any given specific curve. So now that we have the setting of the curve, we have the name of the curve, we're going to create easers for each of these curves by calling the modulators context.modulators.getEaser method. We're going to pass it the name of the curve. We're going to pass it the emitter location for the x's. We're going to pass it the emitter location for x and the spark target for x, and we're going to pass it the lifespan. That's all that an easer needs. It needs to know what kind of curve, needs to know where to start and where to end, and how long to take. And that duration, that lifespan in this case, is in frames. One of the things about tweening libraries for web stuff is that they tend to take an object and just move it. You give it those values and then it goes and moves the object itself or changes the values on it. But in our case, we need to be able to not only do real-time visualization, but non-real-time visualization when we're actually rendering for video. We can't do that in real time. So we have to be able to have a function that we can call whenever we need to get the next value on a curve. And so that's why easers are built into Sinewav. So we get an easer for x, y, and z. We also get one for the scale, because the spark is going to be whatever its size is, and it's going to scale down to nothing. And we're also going to get an ease for the emissive intensity. So it will be, in this case, exponential out. It'll stay bright most of its life, and then it'll fade out very quickly near the end. So we're going to bundle up all this information about the spark into an object. And we're going to have an age, and we're going to, obviously, as we're aging things, we're going to increment that and until it's reached its lifespan. We're going to say it's lifespan, material, the mesh, and the eases. And then we're just going to push that object onto the sparks array in memory and bump the spark count. So that's how we spawn a new particle. How do we age particles? Well, we go through sparks, the sparks array, and for each one we're going to only take action if the age is still less than or equal to the lifespan. So it's still alive, in which case we're going to call the sparks easer for scale and get that value, and if it's greater than 0, we'll go ahead and set that on the mesh. We'll actually scale the mesh. Then we'll position the mesh where it needs to be on x, y, and z. Each x, y, and z have its own ease, so the next number for each one of those values is coming from a different curve. And we're going to ease the emissive intensity, which was 1 to begin with, and it's going to go down to 0 after some time. And then we're going to increment its age. And if we just pushed it past its lifespan, if it's dead, then at that point we're going to remove the mesh from the scene and get rid of our reference to it. And that's spawning and aging. Now we can see how when we spawn, we call a bunch of these methods up here at the beginning to get the number. We got the number just from a reference to a variable, and We get the size by calling spark size method, and the spark size method is going to get the current setting value for the max size of the particle, get the modulator for that size, and then we're going to calculate the size of the spark by getting the current modulator value. If modulator was audio base, then it's going to get the current audio base level and multiply that by the max size. So what's happening is without we have a maximum size of the particle that it can be, and the modulator will limit that by some number. A modulator is always going to give you a number between 0 and 1. And now notice that we also do an OR here. So if there is no audio playing, we kind of still want something to happen. So if audio base is completely dead, then we will use a random number between 0 and 1 to modulate it. And then we'll return the spark size. So you'll see that we have a similar thing going on for lifespan. Get the lifespan and the lifespan mod, and get the modulator value, multiply it by the max life, or a random number between 0 and 1 if the modulator isn't putting anything out. The spark target. So we're going to get the minimum distance and the maximum distance. We're going to find the delta values here, and so we're going to take the maximum distance less the minimum distance, and get a random number between that, between the minimum and the maximum, and then add the minimum. So it will always be at least the minimum. And then we're going to, for each one of those, we're going to flip a coin and either make it be in the plus or minus direction, so it can go in positive y or negative y, positive x, negative x, and so forth. And then we'll return a new point, vector 3, with the current emitter location, which we passed in, plus the delta for x, current emitter location for y, plus the delta for y, and for z. So that gives us where the spark is headed to. Getting that emitter location, now if there's no swing, if we haven't found that this, we need to track some stuff for the swing first. We need easers, and we need to know if they've changed. So if the context.memory.swing object has not been initialized, or if the swing has changed, which we'll get to in a minute, how we check that, then we're going to call setup swing. So if the user has changed to a different ease, then we want to create a new ease and new information for the swing. So after that, we will have an easer for x, y, and z for our swing. And we'll call those to get the next points, and we will pass them back as a vector 3. So we find out if the swing is changed by looking at the context.memory.swing object, and then calling getSwingInfo, which is going to look at settings and so forth, and then it's going to compare the important things to see, did the curve change, did the duration change, did the radius change, did the x base, y base, or z base change? And if so, it's going to be true. Otherwise, it will be false. And now that's how we know if the swing changed. So setup swing calls getSwingInfo, which is going to get the values for the emitter's x, y, and z position into these base values. It's going to get the emitter swing mod, and we're going to get the value of that. If, say, the audio volume is currently modulating the swing, then we'll get the value of the audio volume there. Otherwise, we'll use a random value between 0 and 1. Then we'll get the current swing radius, we'll get the duration, we'll get the curve, all settings that the user has the ability to change but have same defaults. And then we'll calculate the minimum values for the swing, which will be the base minus the radius, and the maximum values, the base plus the radius. So we're going to move somewhere between the minimum and the maximum with our ease. So we'll see that we're going to return an object. This is the swing object that gets stored in memory, and we have the radius, the curve, the duration, the base, x, y, and z, and then we have the minimum and maximum times the mod amounts. Remember, we're modulating the swing by the swing mod, so if the base is pumping, then that is going to be changing. This is going to be a number between 0 and 1 that is affecting the minimum and maximum for each of these axes and so forth. So that's getting the swing info, and then setting it up is basically just creating an easer. We're going to pass it the same curve for each one. It's not going to be as complex as moving a particle around, but you don't see the emitter. It's just a point in space where things start coming out of, and we just want to kind of move it around so everything doesn't look like it's coming out of the same spot. And the curves are going to go between the max and the min values for whatever the swing duration is, times some random value between 0 and 1, so that they don't all take exactly the same amount of time. That gives us a little way of offsetting. Instead of choosing a separate swing curve, the movement on each axis will not be exactly the same. And then we're going to set that to a ping-pong loop. So we set up that easer, and for x, y, and z, they're just going to loop continuously through whatever values are generated there on that curve. And then we're going to set that on context.memory. So that is the code to make sparks fly. Let's go over here and take a look at what this looks like. Create a new project, add a world, throw in my sparks fly copy, and I'm going to give it a background color. The background plugin is defaulting to black, and one of the things about this is that you don't really want to do that in your plugin. Let the user choose what the background color is going to be. Even if I expect my sparks to be against a black background, I'm going to let the user control that, and I don't need to write the code to let them set the background color in my plugin when they have a plugin available to do that. So, just out of the box, this is what we see. So you can kind of see that there is a sort of sinusoidal dance going on there that's moving the emitter around in space. And we can take a look at how that is being affected by, let's reduce the radius. Seeing how it seems like everything is coming out of the same spot. That's the reason for swinging it around. We can change the duration so that the swinging is slower. So now with audio,
spell on you. Cause of mine. Stop the things you do.
Well, I hope that gave you a good impression of how simple it is to use audio modulation and easing in Sinewav plugins to respond to music and move things and change things in an organic feeling way. Be sure to check out the link to the code in the description for this video, or just copy the plugin in Sinewav and mess around with it yourself. Until next time, thanks for watching.